You know, in this absolutely gigantic universe, one of our biggest questions is, are we alone? That hunt for an answer, for a reflection of ourselves, has led us somewhere pretty close, cosmically speaking. Just 40 light-years away, we might be on the brink of finding out.
Our target is a tiny, super-dim star called TRAPPIST-1, and orbiting this little star is something truly special. Not one, not two, but 7 planets.
And get this, these aren't just any random planets. They are all rocky, and they're all about the size of Earth. I mean, that's just an incredible concentration of Earth-like worlds in one place. It's like the perfect laboratory for planet hunters.
Now, scientists have been looking at each of them, and one by one, most have been ruled out. Too hot, too cold, probably no air. But there's one that still looks incredibly good, a planet they call TRAPPIST-1e. So the big question we're digging into here is simple. Could this actually be it?
Okay, so let's zoom in and focus on this one world, because TRAPPIST-1e has this amazing mix of features that puts it right at the top of our list in the search for life. I mean, check this out. It's a rocky world, almost the exact same size as Earth. It's orbiting smack dab in the middle of the habitable zone, that sweet spot where liquid water could exist. It gets a nice steady amount of energy, and because it's so close to its star, a whole year for this planet is over in just 6 Earth days. Wild, right?
But all of that potential, all those perfect stats, they mean absolutely nothing without one crucial thing, an atmosphere. Without it, you can't regulate temperature, you can't protect the surface, it's just a dead rock. So does it have one? Well, that is the billion-dollar question.
To figure that out, we had to call in the big guns, the James Webb Space Telescope. It's really the only tool we have that's powerful enough to even attempt to solve this mystery from 40 light-years away.
So how on earth does it do that? It uses this absolutely brilliant technique called transmission spectroscopy. The simple way to think about it is that we're watching the planet's shadow. As the planet passes in front of its star, a tiny little bit of starlight actually shines through the very edge of its atmosphere, if it has one.
So here's the play-by-play. The planet moves in front of its star. That starlight filters through any air that might be there. Now, different gases in an atmosphere absorb very specific colors of light. So by looking at which colors are missing when the light gets to us, Webb can tell us exactly what gases are in that atmosphere. It's incredible. It's like reading a cosmic barcode.
So, what did Webb find? Well, a team of scientists pointed the telescope at TRAPPIST-1e 4 different times, and the results, or really what they didn't find, were kind of mind-blowing. And here's the thing, believe it or not, this is all fantastic news. Webb's data lets us rule out a bunch of really bad options. So it doesn't have a big, puffy hydrogen atmosphere left over from when it was born. It also doesn't seem to have a crushing, toxic Venus-like atmosphere, or a super thin Mars-like one either. Every no we get for a bad atmosphere actually gets us one step closer to a yes for a good one.
So, after crossing all those off the list, we're left with 2 leading possibilities. First, there's the jackpot. An atmosphere a lot like Earth's, mostly nitrogen, maybe with a big global ocean. The other idea is a world that's rich in methane. Now, that could create some really interesting pockets of habitability, maybe in a Terminator zone. That's the strip of constant twilight between the permanent day and night sides.
But there's a huge twist in this story, a real villain. And it turns out the very star that makes life on TRAPPIST-1e possible might also be its greatest enemy.
Let me put this in perspective for you. Our sun has a massive, civilization-threatening storm, like the famous Carrington event, maybe once a century. The TRAPPIST-1 star fires off a flare of that same power basically every other day. It is just a constant, violent barrage of radiation.
And this isn't a new problem. Stars like TRAPPIST-1, these red dwarfs, they have these incredibly long and chaotic teenage years. We're talking billions of years of violent outbursts. That could have just blasted away any atmosphere the planet ever tried to form, basically sentencing it to be an airless rock from the start.
Okay, so that sounds pretty bad, right? Almost hopeless. But don't count TRAPPIST-1e out just yet. There is a potential defense mechanism that could change absolutely everything.
And that shield is a magnetic field. Right here on Earth, our molten core generates one, and it's what protects us from all that nasty solar radiation. Well, TRAPPIST-1e could have one too. And its super close orbit might actually make it even stronger. The star's gravity is probably squeezing and stretching the planet's insides constantly. That's called tidal heating. And that would keep its core nice and molten and its magnetic shield powered up.
And here is the craziest twist of all. What if the star's violence isn't just a threat? Some scientists think that the very same UV radiation from those flares might be a necessary ingredient for life, providing the spark needed to create the chemical building blocks like RNA. The poison could also be the cure.
So where does that leave us with TRAPPIST-1e? Honestly, we are balanced on a knife's edge, caught between two totally different possibilities for what this world could be.
It really just comes down to these two competing realities. On one hand, we could be looking at a living world, a volcanic, Earth-sized planet with a powerful magnetic shield and a life-sustaining atmosphere. And on the other, a cold, barren, totally airless marble, its potential scoured away by its violent star.
But this story is so far from over. More observations with Webb are already planned. By late 2025, we're hoping to know for sure if carbon dioxide is there, which would be a huge clue. And looking down the road, the Habitable Worlds Observatory is set to launch in 2041, and it is designed specifically for this kind of work.
You know, whatever we end up finding on TRAPPIST-1e, this whole investigation just pushes us one giant step closer to answering humanity's biggest question. At this point, finding life out there is starting to feel less like a matter of if and a whole lot more like a matter of when.